Now that we did a quick overview, let's do some practice problem. The first problem says, find the pH of a solution that have 0.1 HF and 0.15 molarity of NaF. And whenever we do a problem, whether it's buffer or acid or base, we have to ask ourselves, what is in the solution? Is the solution a buffer? And what we have is HF, a weak acid, and its weak conjugate base. And the ratio from base to acid is not greater than 10. Therefore, since it is a buffer, we can just use the Henderson-Hasselbalch equation right away. And at this point, it should be kind of straightforward, where the pKa of HF is 3.14, which I put here, plus log of base, which is 0.15, divided by acid, which is 0.1. And our answer we get is 3.31. Now, I know that the math is kind of easy, but you can also kind of think theoretically. And that is, right now, look at our concentration. I have 0.1 weak acid and 0.15 weak base. What do I have more? I have more weak base. So doesn't it make sense that my pH should be greater than 3.14? And this is true because our answer for our pH was 3.31. The reason I bring this up is maybe on the test you don't have time. You can make a little shortcut like this to kind of eliminate some answers which you're not sure of. Let's do another problem. Find the pH of a solution when 200 ml of 0.25 molarity of KOH is added to 1 liter of 0.1 HF and 0.15 molarity of NaF buffer. And the first question, like I asked, is it a buffer? Now, from the previous problem, we knew right away it was a buffer because we had these concentration. But in this new problem, we don't know what happens when we add the base. And so the way we figure that out is we got to use a limited reagent table. Now, I wanted to slow it down right now because when we do a limited reagent problem, we have to use moles. And this is super important. We cannot just plug in the molarity values. We have to use moles. And so how can we find moles? Using this formula. Molarity equals moles over volume. And so I did the KOH right away, where I just did 0.25 molarity times 0.2 liters, which is 0.05. And then how much moles of HF do I have? Now, I actually missed a step. Let's take it slow, right? We're adding KOH, right? Does it want to react with acid or base? The base wants to act with acid, right? And so before, when you think about doing a limited reagent problem, I would highly recommend writing down the whole equation like this, okay? And so we're reacting weak acid plus KOH, that gives us weak conjugate base. And like I mentioned before, we know how to find the moles of KOH. Now, how do we find moles of HF? Well, we have molarity and volume, and therefore the moles should just be 0.1. And the moles for F minus is molarity times volume is 0.15. I want to emphasize one more time, when we do limited reagent table, make sure you have the initial number of moles correct, okay? And just like last semester now that we know our initial moles, subtract the smallest reactant, so which is 0.05, and then we add 0.05 to the product. And therefore, how much HF do I have after react? And now this F is final, is 0.05. All the KOH is gone, and then we have 0.2. And now that we know the final concentration, we got to ask ourselves, do we have a buffer? And yes, we do. Why? Because we have a weak acid and its weak conjugate base, and then the ratio of base to acid is still less than 10. And therefore, we can plug in the numbers. pH equals pKa plus log over base over acid. pKa, which I gave to you guys, is 3.14 plus log of base. Now, we have base here, 0.20 moles. Do I plug in this number right away? No, because Henderson-Hasselbalch equation for buffer is in molarity. And this is super important. Just to recap, limiting reagent is in moles, but then when we want to use the Henderson-Hasselbalch equation, it has to be in molarity. So how do we find molarity? Molarity equals moles over volume. And then the moles of the base was what? 0.2. And what was our total volume? 1 liter plus 200 ml, which is 1.2 liter. Okay? And so the concentration for base is what? Let me put a calculator. 0.1667. Okay? So that is what I'm going to put for B. And then what's the concentration of HF? Well, we have the moles was 0.05. And our volume was 1.2 liter. And therefore that is 0.0416. Right? So I'm going to put that down here. And so if I plug in this number right here, I should get 3.14 plus log of 0.1667, 0.04166. And let's see what my calculator says. Such a small number. It's 3.14. 0.167 divided by 0.166. 3.14 plus 0.6. I get 3.74. Sorry for the delay. Okay? And so I just want to do a quick recap. What's going to happen is whenever they say find a pH of a solution, you need to first ask yourself, what is my final concentration? And then, is it still buffer?